Hello guys, I've been slow to make a video on the PC400 for a while because I've been working on the slew mechanism and trying to come up with a good way to do that the model will still be pretty strong. So as you can see, I got part of the way through there, but I'm not going to worry about that today. I'm going to leave that for the time being, and I'm going to work on the tracks today, and more specifically getting the motors to work with the tracks that we have. I've recorded half the slew mechanism video, but I'm going to leave that for another day, and instead today I'm going to work on the tracks, and particularly getting the motor to attach to the tracks somehow. So on the body of our model here we had this little fake gear. Unfortunately this fake gear doesn't have any teeth in it, so it won't attach to our track that we have here. So we're going to have to come up with some way of connecting that to the track, and it also came with this little piece here on the end that just pinned it in place here. So that would have been a static piece with the fake gear spinning around outside of that. So what I'm thinking to do to connect our N20 motor to our gear is to use one of these wheels, or well, the center of one of these wheels. You see, this already has a 3mm D shaft in it, so our N20 motor just fits onto that. No problem there, just slides on. And if we take a look at the diameter of that inner shaft there, we'll see that it's around about 8mm. So if we could cut that inner shaft out, we'd have an 8mm insert, and then we could just drill this out, because at the minute this is 7mm, around about 7mm. So we could just drill this out to 8mm, push the insert in there, glue that in. I'd cut a piece off this and glue this on here. So the Komatsu symbol is going to be spinning all the time as the tracks go around. But what can you do? It's going to be okay. It's either glue it in place or get rid of it. So I think I'll just glue it and it'll look good enough. So there's the little insert cut out. So we just need to drill out this little gear here so that we can fit that in. So the next thing I need to do is drill this out to 8mm. I'm going to have to be very careful doing that because this cylinder in the middle isn't very thick. So when we start drilling it away, it's going to be considerably weaker. But once we glue this piece back in, that should strengthen it back up again. So just need to be careful during the drilling so that we don't damage it then. I've drilled this piece out to 8mm, and our little insert thing can slide in. But I haven't filed the insert around properly yet, so obviously the motor won't fit on because it's actually squeezing in at the top here where the little gap is. So what I need to do is round it off a bit, but what I'm going to do is when I want to put it into the gear here, I'm going to place the D shaft in it, and then I'll know where I have to file off, or what areas are tight. So with a little bit of filing, the insert will fit in there, no problem. We just need to glue that in place, and that will be the drive to the gear sorted out. But we still can't connect the gear to the track yet, so that's what I'm going to work on next. My first idea for this is to take some of this thermoplastic here, which is material that you just put into some boiling water, and then you're able to, mold it into different shapes. So that's what I'm going to try first. I'm going to heat some of that up and then push it all into the space in the gear here so that it's nice and compact. And then I'll heat it up again so it's malleable again, and I'll just get the track and I'll push the track down onto the hot plastic so that these little grooves that are in the track here, they should mold into the thermoplastic. Now I've no idea if these little teeth will line up the whole way around the gear, so we're just going to have to try it and see how it works. It might work, and if it doesn't work, we'll just come up with a different idea. So here's some boiling water. I'm just going to try heat up some of this plastic, mix it up, and hopefully we'll make our gear. So using the water is the way you're supposed to do it, but if you have a hot air gun you can heat this up a lot faster. So that's what I'm going to do. Just be careful when you're heating it up that you don't set it on fire. It's probably easy enough to set this plastic on fire if you hold the heat gun on it for too long. Now I have the plastic completely in the gap here in the gear, so I'm going to heat it up again and try and imprint the track on the gear here. It's kind of hard to do in front of the camera, so I'm just going to do it and show you the final result in a second. Here's the gear. It looks like, well, initially looks like it's worked pretty perfectly. In fact, you can see our little teeth now in the gear. Because I had it so full, I need to trim down these little pieces where the plastic stuck up. This is where the track met on the other side of the gear, so I tried to run the track this way and then run it back, and I pulled some of the plastic up, but it looks like those two holes are pretty perfectly aligned. So what I'll try and do is just trim all this down and then see will this gear run on my track. Unfortunately, I wasn't able to get the thermoplastic to take a shape that the track could continuously run around on. So the next idea that I had was to remove quite a bit of this plastic from it and make a smooth inner layer, onto which I put an O-ring. So the O-ring is on the gear here. So with any luck, now when we put the gear back on and we put the tension on the chain, the friction between the rubber O-ring and the tracks will hopefully be enough that we'll be able to drive the track around. Now, the only way we'll really know whether this will work is to actually test it out. So I'm going to make up one of these gears, try and make up at least one side of this with an N20 gear motor. Then we should be able to see if the track is going to drive or not. Hopefully it will. Okay, well, I have a motor set up here on the chassis of the excavator, so I'll just hook up some power and show you. This motor is just sitting in here, so it's not mounted properly yet, but there's enough tension on the chain to show you it working. So you can see there our tracks are working, no problem. And this is just with the O-ring design now. If I push down, I'm not sure if the motor's struggling because the battery is flat or because it's under a lot of load. Now I'm only using 3.7 volts here, but when I actually do this I think it'll be closer to 12 volts that I use. So the motor should have no problem spinning around then. I just got a 7.4 volt battery, so this should be a little bit more power now. See there, seem to have loads of power. So with any luck, when I get the other motor mounted on the other side, this setup should work pretty perfectly for our excavator. Well, I was getting on great here until I broke the second gear motor. What I did, I think, was I moulded it too far forward, which made the track too tight. And then I done something very stupid. I tried to force the track around to get it started, but I ended up just breaking a tooth in the gear, well, in the gearbox of the N20 motor. So that has put an end to this for this week. So I'm going to have to get a replacement gear motor for this side. I'm not even sure what gear ratio that was. So I'll figure out whatever that motor was and I'll finish that off. The next video should be the slew mechanism here somewhere. At the minute it's proven a little bit tricky, but I think I have an idea now. And if that works out, hopefully you'll see that video in the next few weeks. So that's all I'm going to be able to do this week. If you've any comments, post them below or post them in the forum and I'll try and answer them. And if you like this video, make sure and hit the thumbs up button or hit the like button. And that's pretty much everything. So thanks very much for watching.